let's look at the effective versus nominal rates of interest. So to explain the difference between these two concepts, first let's look at an example. So suppose we have two different banks. The first bank is ING Bank. So they're quoting a rate of 8% per annum compound annually on deposit placed with it. So that means you deposit money with ING Bank, they will calculate the interest once per year. And the annual rate, which is the nominal rate of return, is 8%. At the same time, there's another bank, HSBC. So they're quoting 7.8% per annum compound monthly on fund deposit with it. So in this case, HSBC, their nominal rate is 7.8%, but instead they calculate your interest 12 times in a year, which is monthly. So let's calculate the difference. So at the annual rate of 7.8%, so if we convert this into monthly interest rates, so it is 0.65% per month. So that's that's because of the conversion periods, 12 in a one measurement period a year. So consequently, if we deposit $1 with HSBC for 1 year, what will happen is that you will receive your interest will be compounded 12 times in a year. So your actual interest or your kind of effective interest rate will be 1 times 1.0065 to the power of 12. Right? So I can skip the process of calculation. The result is 1.08085. So if you compare the effective rate of HSBC's product with the effective rate of ING Bank, you realize that the actual return of HSBC will be higher than ING, despite the nominal rate of return of HSBC is only 7.8%, while ING is 8%. So this actually very well explains the difference between the so-called effective and nominal rate of interest. So then we replace those numbers with symbols to make the explanation more generic. Remember, we previously said we use R as the nominal rate of return. M is the number of conversion periods in one measurement period. So M here can be 12 months in a year. And what you would do is that you use the nominal rate divided by the number of conversion periods in one measurement period. Then you put them together and to the power, compound to the power of n, which is 12 times in a year. And so this you will receive equals to 1 plus I. I here is the effective rate of return. So this is the formula or equation of calculating or converting between effective and nominal rate of return. Right? So if you want to calculate the nominal rate of return from the effective rate of return, right? You just do the opposite, you convert it, and this is the equation. So some of you may wonder, or some of you may already have found that the more frequent we compound in the measurement period, the higher the effective return will be. So let's just push this to the extreme. We know that we can compound monthly, weekly, daily, hourly, right, minutely. Or how about we just do it like continuously? So we compound every single second or even tiny bit of time. We could just do that. What the effective rate of return would be, right? So in that case, what will happen is that we increase the number of conversion periods in the measurement period to the extreme, right? To infinite number of conversion periods. And some of you probably have the knowledge of mathematics and remember the definition of E, which is Euler's number, right? So this is how we calculate E. So if you remember that and you replace part of this equation with the E, what you receive that is the effective annual return with continuous compounding is E to the power of R. R here in this case is nominal rate of return minus 1. So this is how we convert from the nominal rate of return if we compound interest continuously. That is really the extreme you hope to get, right? Because no real banks or lenders will use this, because that just is not very commonly used. So now we have the example here to show the difference because caused by the conversion frequencies. And suppose we're now depositing $100 for 1 year, and the nominal rate of return is 10%. So in the case of only one conversion period, measurement period, which is to calculate interest only once per year, so the total amount of the balance you will have by the end of 1 year, which is only $100 plus $100 times 10%, you receive $110. So if we do this twice a year, then your total amount of capital you will have by the end of year one will be $110 plus 25 cents. If you do it quarterly, monthly, and daily, you receive different amount of returns. And extreme kind of condition of this is to compound the interest continuously. So in that case, the total amount of the capital you will have by the end of year one will be $110 plus 51.71 cents. Right? Seems to be only slightly higher than, say, quarterly or monthly. But if your initial capital is way higher than $100, say $100 million, then difference between this and the annual kind of conversion period frequency will be substantial. So this is the difference between effective and nominal rate of return, and that is the power of conversion frequency. Thank you.